Hi everyone, this is a video to show you how linear equations can be used outside the classroom. Now, linear equations can pop up in all sorts of places, but the place I find these most often is when I'm comparing two deals, such as car insurance or energy companies that might differ depending on certain factors, so factors like the duration. Now, comparing phone contracts is a good example of this because it can depend on a lot of factors, as you might want certain things including, such as like the data package or the amount of minutes and text you get. But the example I'm going to talk about is one where I had to use linear equations in order to see how the price changed for two equations, as sometimes one was cheaper than the other depending on what I inputted to it, and here's why I needed to do that. So my car's head gasket broke in a car that I'd not long bought, but luckily it was still under warranty. So I had to drop the car off at the garage so they can fix it, but I didn't get a courtesy car, which meant that I needed to get a car from elsewhere. So I ended up looking at renting a car through a comparison website and found two cheap deals that worked quite well. And the first deal is from this one here, which I've called Company A, as I'm sure I'm not allowed to say the company names. And Company A offer this car or something similar for £17.80 per day. But there's always extra charges for these types of things, and they're usually hidden. So after doing a bit of digging, I found out exactly what the extra charges might be. So I wanted an additional driver on the car so my partner could use the car as well. So with Company A, the additional charge for that was £97. So it was just a fixed rate of £97 for additional person for the car hire. And there was also a charge for being under 25-year-old, which they classified as being a young driver. So this meant I had to pay an extra £35 per day on top of that because I was under 25. Now, there's quite a few things to consider here. That's depending on the amount of days I want to rent the car for. So the easiest thing to do is create an equation. So if we call y the absolute total final cost I need to pay, and then x the number of days that I'm going to use the car for, then we can say that y, which is the total cost, is equal to £17.80, and we're going to times that by x, so that if I just want it for 1 day, it would do 1 times £17.80, but then if I wanted 2 days, it would also do 2 times that. So if I multiply it by a variable, it will let me vary the amount of days that I want to use it for. And then we need to add the young person's charge of £35, so plus 35. And then this is also per a day, so this also needs to vary depending on the amount of days we use it for. So we'll make this 35x. And then for the additional driver, we have a fee of £97, and that's just one fixed flat rate. So we'll put plus 97 at the end, and then if we were to simplify this a bit, we can have y is equal to 52.8x plus 97. So whatever the number of days I wanted to borrow this car for, I can just substitute it into x, and then it will spit out a value for y, which is my total cost. Now the second deal is this one here, which we'll just call Company B. So the cars look very similar, that's just because it's on a comparison website and it's using its own images, but it's just suggesting that the company is going to offer a car that's very similar with the same spec. So Company B is offering £18.86 per day. Then after doing a bit of digging, the additional driver cost was £13 per day, so there wasn't a fixed rate, that did vary. And then the young person's charge was a little bit more at £39 per day. Now the reason why I was interested in this deal is because the additional driver charge wasn't a fixed rate, it was per a day at a much lower rate. So it could work out cheaper if we go with this deal. So this deal would mean our equation would be y is equal to 18.86, which is the cost of the car hire per day. And then we'll stick an x with that just because that varies in the amount of days we're going to use it for. Plus 39, which is the young person driver charge. And then that also varies in the amount of days, so we'll put an x with that. And then plus £13, which is the additional driver charge, and then that also varies depending on the amount of days, so we also need to put an x with that. So that means we can simplify this to 70.86x, and that's because all them three factors all depend on the amount of days we're using the car for. So we have our two equations. We have y is equal to 52.8x plus 97 for Company A, and then for Company B, we have y is equal to 70.86x. So we can see that the second deal does look cheaper, as we have y is equal to 70.86x, and the charge for additional driver on the first car is already greater than that amount if we were to use the car for 1 day. So I just want to go over to Excel here and see what prices we'll get if we want to rent the car for different durations. So I've just got Excel open here. So if we create just a little box just to put the details of the offers in. So we have Company A and Company B. And then the charges we have is for the car, additional driver, and young persons. So if I just put all the details in, so we have 17.8, 97 and 35, and then 18.86, 13 and 39. And then just under it we'll create a column of days, so we have days, and then we'll do 1 to 14. And then we'll have a column for Company A and a column for Company B. So in the first column then here, what we'll do is we'll set up our equations. So we have the price of the car times by the number of days, plus the price of an additional driver, which is a fixed rate at 97, plus the price of a young driver times by the amount of days. So then that's the first equation sorted. So the second equation for Company B, we have the price of the car, which is £18.86, times by the number of days, plus the price of an additional driver times by the number of days, plus the price of a young person times by the number of days. So we've got our two equations set up here, and what I'm going to do is just quickly absolute reference them, just so when I dread down the formulas it won't mess up. So if I just quickly do that. Right, there we go. So now if I highlight these two and then drag them down to 14, it will use the number of days as the X value, which will create different prices for me. So we can see up here when we're using it for 1 day that Company A is more expensive, so I'd go with Company B. And then if we were using it for 2 days, Company A would also be expensive, so we would go with Company B. And then what I can do is actually just create another column, and I'll call this which is better. And then we can say if Company A is less than Company B, then write Company A. If not, write Company B. So this should now tell me which company is cheaper for the amount of days. And if I drag this down, we can see that when we rent the car for between 1 and 5 days, then Company B is the better option, so that's the cheaper option. But if we were to use the car for more than 5 days, then Company A is the better option. And this is because Company A has a fixed cost of £97 for the additional driver, whereas Company B has a variable cost of £13 with no cap. So there's a cap to the additional driver cost for Company A, but there's no cap for the additional driver cost for Company B, which means eventually the additional driver cost of Company B is going to outweigh the additional driver cost for Company A. And in fact, we can actually use Desmos to graph the two equations to see the point where the Company A becomes cheaper than Company B. So I've just loaded Desmos up here. And then if I were to quickly plot y is equal to 52.8x plus 97, and then our second equation of y is equal to 70.86 and then x, then it will plot two lines which we can see aren't actually parallel. So this means that they will cross at some point, and at that point it crosses is where the amounts for y are the same, so where the total is the same. And then after that point, Company A starts to become cheaper. So let me just adjust the axis here so we can see it more clearly. So now we can see that the point where they intersect is when x is equal to 5.371 and when y is equal to 380.56. So this means anything under this point means that Company B is cheaper, but anything above this point means Company A is cheaper. And remember that the x-axis is the amount of days, so we're going to see this happen as x increases. So as x increases, which is the amount of days I need to use the car, the company that offered a cheaper offer also changes. Now the garage I was with wasn't sure how long the car would be with them, just because they needed to order a new part, and this was just after lockdown, so some of the suppliers weren't open, but this meant it would be at least a week, which meant I obviously went for Company A. making it at least £30 cheaper than auto holidays. So if we go back to Excel here, we can see that because it was more than the 5 days, it was at least £30 cheaper. And the difference of that obviously increased the longer I had the car for. So I think I ended up using it for around 10 days, which meant Company A was cheaper of about £83.60. Now, had I not checked using these linear equations, then I could have easily assumed that the Company B was the better option, especially if I didn't check the terms and conditions for the additional costs and stuff. And that's because it just looked like a better offer in terms of the numbers were quite low in the equation. But it meant it was definitely worthwhile using linear equations to make sure I was actually getting the best offer. Now, as always with these relevance videos, I don't expect you to fully understand the maths behind everything I've discussed. But I do hope you do now have an understanding that linear equations can crop up anywhere, especially when you're comparing stuff, and they can actually be quite useful in making decisions. You just sort of have to have a general understanding of how to set one up. But once you've done that, everything else is easy. It's just about plugging different values in and then seeing what the outcome is. But anyway, I hope you've enjoyed this example, and for now that is the end of the linear equation relevance video.